Hello and welcome back. In section 7.1, we look at functions of several variables. So the idea here is basically just that we have multiple inputs. So for example, we might have a function f of xy. And there will be some relation between the x's, the y's, and this you could think of as z would be sort of the generic third variable. So f of xy for this one will be 2x squared minus 3 times xy minus 5. And they can ask us to do different things with that. We start with sort of a straightforward find f of 0, 1, for example. So this is just saying, okay, replace all of your x's with parentheses and drop zeros in them. All of the y's turn into 1s in parentheses. So all the constants and exponents and such stayed the same. So all of my x's are zeros. All of my y's are 1s for this one. So then we're just simplifying that. So f of 0, 1, we have 0 minus 5 is negative 5. They can give us the same one and ask us for 3 times f of 1, negative 1. Minus 7 times f of negative 2, positive 3. Same idea, just sort of building it a little bit more. So 3 times the result of plugging in 1 for the x, negative 1 for the y. So 2 times something squared minus 3 times 2 somethings minus 5. So all of my x's are 1s in parentheses. All of my y's are negative 1s in parentheses. And then we have minus 7 times, and do the same thing. 2 times something squared minus 3 times 2 somethings minus 5. And all of our x's are, this one, negative 2s. All of our y's are positive 3s. So we have 3 by 2 plus 3 minus 5, minus 7 by, that would be 8 plus 18 minus 5. So then we're just plugging and chugging away on the arithmetic there. So we have 3 by 0 minus 7 by 21. So negative 147. So same idea, just multiplying by a scalar multiple. All right. So next up, we'll look at a common 2-input function. We'll do P of LW will be 2L plus 2W. So that one, you might recognize this as sort of a different way of writing down something you've been doing since grammar school. This is just the perimeter of a rectangle, just written in terms of a multivariable function. So if they asked us for P of 710, L gets replaced with 7, W gets replaced with a 10. So P of 710, 14 plus 20 is 34. So we'll do one more kind of common geometry application next. So we'll look at cap S of our H. It's going to be 2 pi r squared plus 2 pi times r times h. This would be basically the surface area on a right circular cylinder, a soup can, if you want to think of it that way. So here's our base with radius r, height h. So the soup can has a top and a bottom, area of a circle, pi r squared, and we have 1, 2 of those. The label, if you will, peeling the label off of the soup can, if you flatten it out, you've got a rectangle. Well, we know the height is h. The length of the label would be the same as the circumference of your circle, pi times diameter, and the diameter is 2r, of course. So this is another not terribly uncommon geometry formula that can be expressed in multiple variables. So they could ask us for s of, say, here, 5025. So 2 times pi times, they told us the radius was 50. Radius again, 50. And the height was known to be 25. So s of 5025. So 50 squared, 2500 by 2 is 5000. So 5000 pi plus 2 by 25 is 50. 50 squared is 2500. And we have our times pi. So s of 5025 would be 7,500 times pi. That would be in square whatever units that we're working with, since this one happened to be a surface area. In the context of the problem, they didn't necessarily give us that information just yet. So far, just plugging and chugging two values in for two constants. Occasionally, they'll give us just one of those. So for example, they might tell us that f of x is worth cap g of x comma 2, and that cap g of xy is x cubed minus 2x squared y plus xy squared minus y cubed. So if they ask us to find f of x, so f of x is, by substitution, cap g of x comma 2. So this is saying that all of my x's stay x's, all of my y's are now 2. So x cubed minus 2x squared, there's a y, 2 in parentheses instead. Plus x, there's another y, 2 in parentheses instead. Outside of it, we have a square, a minus sign, there's another y, 2 in parentheses instead, and a cube. And we just simplify where we can. So f of x is cap g of x2, x cubed minus 4x squared plus 4x and minus 8. I don't see any like terms, so that's as far as we would go on that guy. So let me give you one where we can go one step further. And here, for space sake, we'll just flip to the next page. So we'll take a look at cap f of xy is xy cubed plus 3xy squared. And I'm going to ask you to not only do what we did in the last problem, but also apply it one step further. So you're going to find all y st such that cap f of 4 comma y equals 0. So a hint, first you're going to have to find cap f of 4y, then set it to 0 and solve. So go ahead and pause it, at least try to get yourself as far as finding cap f of 4y. Okay, welcome back. So cap f of 4 comma y says all of your x's are turning into 4's in parentheses. The y stayed a variable, so all of those stayed variables in this as well. So cap f of 4y is 4y cubed plus 12y squared. So that's part one of the problem, is just finding cap f of 4y. Second part is then, okay, solve this thing, set it to 0. So 4y cubed plus 12y squared. They want to know where that's equal to 0. And that's just factorable over the integers. Factor of 4y squared, and you have y plus 3 equaling 0. So either your 4y squared is 0, or your y plus 3 is 0. So y is 0, or y is negative 3. So there's two places on the y values that we have an x coordinate of 4 and an output of 0 for the function value. In other words, z equals 0. So that would be at 4, 0, 0, and 4, negative 3, 0. Okay, they do let us practice a little bit of something resembling our friend the difference quotient. So let's see, so for this one, f of xy is going to be x minus 2y squared. And we're going to find f of x comma y plus k minus f of xy, all divided by k. So we'll just find one piece at a time and then use a little substitution on it. So first I'm going to find f of x comma y plus k. So f just gives us the name of the function, x stays as is, all of your y's are now y plus k's. And we had a squared on the end there. And you're hopefully remembering at the calc level, a plus b quantity squared is not the same as a squared plus b squared. So f of x comma y plus k is x minus 2 by y plus k by y plus k. So f of x comma y plus k, x minus 2 by, and go ahead and FOIL that out, y squared plus 2 times k times y plus k squared, and then go ahead and distribute your 2. So we'll have the sort of first piece of the puzzle. So x minus 2y squared minus 4 times k times y minus 2 times k squared. So we have this piece of the puzzle. We already had the original, so we're ready to set up our difference quotient. So f of x comma y plus k minus f of xy all over k. So that's my left-hand side. So notice the left-hand side has changed. Now it's no longer just this one piece. Now it's the whole thing. So we would have x minus 2 times y squared minus 4 times k times y minus 2 times k squared. Close it up. And then minus the original x minus 2 times y squared, all divided by k. And we have an x minus an x. We have a minus 2y squared and a minus negative 2y squared. And we can factor a k from everything we have. So f of x comma y plus k minus f of xy, all divided by k. Factor k from upstairs, we have negative 4y minus 2k. So we had 2 of them there, all divided by k. And assuming k is non-zero, that'll drop to a 1. So f of x comma y plus k minus f of xy, all divided by k ends up as negative 4y minus 2 times k. And that's as much as we can do simplifying that guy. All right. So next up, we have a couple of our friends, the word problems. So we have, next one is going to be a production. So a company makes 2 models of whatever we're selling. This one, they have it as swings. So model A, variable cost of $150 each. So it costs the company $150 every time it makes another swing on model A. Model B, variable cost of that one was $100 each. And the company is known to have fixed cost of $5,000 per month. So again, remember with the fixed costs, that's things like rent. The landlord wants their money no matter if business was booming or if you were playing games on your phone and didn't have any business going on at all that month. The landlord wants the same amount of money no matter what. So that would be an example of a fixed cost. The variable cost, the more of the material and labor you need to make more and more of whatever the units are, A and B of the author had us looking at swings for this one. So then for this one, the cost function would be C of AB. So this is, we'll assume monthly like the fixed costs were. So variable costs $150 per each of model A that we make, and we'll make A of those. $100 per model B, and we're making B of those, and an additional $5,000 going out the door. So they have us looking for C of, what do they pick? 75 and $1.50 and interpret. So in other words, not just find the number, what does the number mean? So first off, we'll just follow their model. So C of 75, 150, similar to what we've been doing, 150 times whatever number they gave us for A. In this case, they said use 75 for that. Then we have plus 100 times whatever number they give us for B. In this case, they said 150 for the B value, and then plus 5,000. So C of 75, 150. So we're just kind of plugging and chugging real quick here. So we've got, let's see, 11,250 plus 15,000 plus 5,000. So basically, this is our cost for making 75 of Model A, our cost for making 150 Model B, and adding all three together, so the two variables and the one fixed, would be our total monthly cost. So C of 75, 150. Let's see, we have a 250 at the end there, so 20 and 11 is 31. So that's the find part, the interpret part. So the monthly cost to make 75 of Model A and 150 of Model B is, and these are being measured in dollars, so $31,250. Dollar sign goes in front of the number, not behind. That's some weird thing I've seen crop up in the last 2 years. Dollar sign is in front, not in back. Okay, so one more word problem, our friend the word problem, the applications. So here we're going to make an open top box. So basically, think of a rectangular solid, and we have no lid. So here is our famous open top box. So the top of this is just open, no material needed for that. We have 5 other sides then. So H is going to be our height, W will be our width, and L will be our length. So we're going to find the total material and based on the 3 variables. So pause it, see if you can figure out the equation for that, just reasoning it out based on the sketch. Okay, welcome back. So here we would have M of, we have a length, a width, and a height. So 5 surfaces. The bottom surface would be length times width. Left and right side, we're adding more area on, and we have 2 of those, a left side and a right side, each of them length by height in area. Plus, we have a front and back of the box as well, so 2 of those, and each would be width times height. So that would be our model to represent how much material we need based on the 3 inputs. They may also ask us to evaluate for M of 6, 5, and 8. And we'll also interpret what that means. So M of 6, 5, 8 tells us that all of our lengths are going to be replaced with 6s. So notice there I set up the skeleton of it. 2 variables multiplied plus 2 times 2 other unknowns plus 2 times 2 other unknowns. So all of my L's are turning into 6s. All of my W's are turning into 5s. And all of my H's are turning into 8s. So M of 6, 5, 8. So 30. So 30 square inches for the bottom piece. Plus Let's see, that'd be 12 by 8, 96. That's 10 by 8, 80. So M of 658, commas in between. So we have 17 and 3, 20, 206. So what does this 206 actually mean? And what do these three values mean? So this means that we're saying to make a box, we'll assume these are in inches, 6 inches by 5 inches. That is 8 inches tall. 206, this would be then in square inches. Square inches of material is needed. Now, practical application to that, you would want to sort of overestimate. You will lose some material in the folding if you were actually making the physical object, but for the purposes of the textbook, we assume that you're getting everything done exactly perfectly. All right, so some problems I would recommend trying out. This was in section 7.1. Try out 9 through 19 on the odds. 23 to 35 also on the odds. 47, 49, 53, 55, 67, and 72. So those were some good application problems similar to what you'll see coming up on some tests and such. If you have any questions, as always, please feel free to reach out and get in touch with me. Otherwise, I'll see you next time. Stay safe out there.